Good day, everyone. Welcome back once again. We're looking today at the topic 5.3 in the polynomials unit of Math 10C. This can be found on page 12 of your West Country Outreach unit handout. And we're going to be looking at factoring polynomials that look like x squared plus bx plus c. So that's our goal, to factor those polynomials. And you're going to recognize this type of polynomial. It becomes very familiar after a while. We have in Math 20-1 two entire units, approximately 1/4 to 1/3 of the course, dealing with these types of mathematical expressions. And they have a special name. They're called quadratic expressions. And because there's three terms, they're called a quadratic trinomial. It doesn't have to be x. It can be r squared plus br plus c. And all you need to know right now about b and c is b and c are numbers. This will become clear as we work through some examples, so let's get going here. Warm-up number 1 asks us to do something. It says expand x plus 3 times x plus 5, and then explain the relationship between the coefficients of the resulting quadratic polynomial and the numbers 3 and 5. Well, let's expand this first of all. We have x plus 3 multiplied by x plus 5. We use FOIL, of course, and beginning of the lesson, so I'll just do this in slow stages. FOIL means x times x in this question. Outer means x times 5, which is 5x. Inner means 3 times x, which is 3x. And last is 3 times 5, which is 15. So the expanded form of the factored form, x plus 3 times x plus 5, gives x squared plus 8x plus 15. And what we were asked to do is explain the relationship between the numbers 3 and 5, which appear in the factored form, and the coefficients of the quadratic polynomial. So the question is, what is the relationship here? And I'm going to write this out. How are 3 and 5 connected to 8 and 15? That's what the question is. How are these two numbers that I'm going to highlight in yellow, what's the connection between them and the two numbers I highlight in blue? And there is a connection. If I take the two yellow numbers and I add them together, I get the number in front of x. And if I take the two yellow numbers and multiply them, I get the constant term in that trinomial. So we're going to add to this in more detail in a bit, but for the time being, what we can do is say that 3 plus 5 gives me 8, and 3 times 5 gives me 15. And I want you to note that 8 is the value of b. It's the coefficient of x. When we write x squared plus bx plus c, b is always the number in front of x. So when we add those two numbers in the factored form, 3 and 5, we get the number in front of x. And when we multiply those two numbers, we get the constant term, which is c. When you look up top here, c is the constant term. It's the number by itself. Does the relationship above seem to hold true for two binomials that are always of this form? So I've just made up some symbols here. Well, I didn't make them up. I put in some symbols. So the question is this: does it seem to work for this, for example? If we expand this out, will the coefficient in front of x be the sum of those two numbers? And will the number by itself be the product of those two numbers? That's what the question is. So, for example, if I had x plus 4 and x minus 3, according to this rule, will I get x squared, and then the number in front of x is going to be the sum of the 4 and the negative 3. Well, the sum of those two numbers is 1. And will the constant term be the product? Well, the product of those two numbers is 12. This is what we are asked to explore. So how do I do this? Well, I use FOIL. First means x times x. Outer means x times 9. Inner means 2 times x. And last means 2 times 9, which is 18. And you can see that it checks out. And I think at some point, many of you will understand why it checks out. Why are we getting 11x? Because the product, outer and inner together, are 9x and 2x. So it works here. That is to say, the sum of these two numbers gives us this, and the product of those two numbers gives us this. Does it work for negative numbers? Well, let's see. My first here would be x squared. My outer would be negative 3x. My inner would be positive 4x. And my last would be negative 12. And you can see that it checks out. These two terms are going to give us 1x. And that's what we have. Once again, if you take these two numbers and you add them together, you are going to get the coefficient of x. And if you multiply them, you're going to get the constant term. So, yes, it works. Now, there's some conditions to it working. One of the things is that we have to have 1x in all of these, and you have to get 1x squared. If it's not in this exact form, everyone, if it's not x plus something and x plus something, it won't work. If it's 2x plus something, it won't work. If it's 5x plus something, it won't work. It has to be 1x plus a number times 1x plus a number. So, yes, does the relationship above seem to work? Yes, it works. And I don't want to get into a proof here, but I think many of you will see why it has to work. So what have we learned? If you have x squared plus bx plus c and you factor it, so I want to just go through some terminology here. There are two forms to this. This is called the expanded form. And this is called the factored form. If you factor that quadratic trinomial, which means you turn it from expanded form to factored form, the fact of the matter is the two numbers involved have to add to give b and have to multiply to give c. If you're not happy with those weird symbols, if I write x squared plus bx plus c equals, in factored form, x plus p times x plus r, what we are saying is p plus r has to give you b, and p times r has to give you c. And this is the lesson. This is it. Now we just have to practice it. Some of you struggle with your times table, and I understand that. It's better if we don't have to poke around blindly on the calculator to find numbers that multiply to give certain things. For that reason, if you really struggle with your times tables, please come see me at the school, and I'd be happy to provide you with a printed times table that you can use while you're practicing. Of course, you cannot use it during exams. So let's get some practice here so this sinks in. Factor the following and check by multiplication. First of all, will this work? Does this qualify as being one of those trinomials? Yes, because it's 1y squared plus 4y plus 3. Because this coefficient of the first term is 1, this will work. So we're going to factor it by just setting up a template and putting y here and here. So now we ask ourselves what the numbers are. We want two numbers. Doesn't matter how I symbolize them. I'm going to say that's one number, and here's the other number. We want two mystery magical numbers that are going to add to give 4. And those same two numbers are going to multiply to give 3. And I realize that many of you will be very good at this, and that's great. That's the goal. Some of you will need more time, but I am starting off with one that's fairly simple. What you want to do is start by considering your multiplication statement and make a list of pairs of numbers that multiply to give 3. Well, 3 times 1, and that's the extent of our list. You're not going to get any other numbers that multiply to give 3. So if we go 3 multiplied by 1, that gives us 3. And that satisfies that statement. The two numbers multiply to give 3. Now what we do is we check to see, do those two numbers added together give us, well, what do they give us? They give us 4. And we look up top and we see that that in fact is what we want to get. So the two numbers that complete this factorization are 3 and 1. So it's going to be y plus 1, y plus 3. You can put the 3 and the 1 in either place. Now it does ask us to check this by multiplication. So when I look at first, outer, inner, last, I get y squared. Well, that's good because I want a y squared. Jackpot. At the top of the screen, I can check off y squared. My outer is 3y. My inner is 1y. And my last is 3. So my last is 3. That gives me the 3 at the top of the screen. And the 3y and the 1y gives me 4y. So this is the answer to the question. This is y squared plus 4y plus 3 in factored form. X squared minus 5y minus 4. Well, if this factors, it's going to factor into an x and an x here and here because this is 1x squared. And we are going to be looking now for two numbers that add to give negative 5 and multiply to give 4. Now, not everybody will pick up everything I say in any of these lessons. But if the two numbers add to give a negative and multiply to give a positive, the only way that's going to happen is if the two numbers are negative. For example, negative 2 multiplied by negative 2 gives you positive 4. In fact, if that's your starting point here, then you can say, yep, that worked. However, if we take those same two numbers, negative 2 plus negative 2, that gives us negative 4, and that does not match what we should get. That's a wrong statement. We should get negative 5. So the numbers are not negative 2 and negative 2. Well, what else could they be? What other numbers multiply to give 4? Well, 1 and 4 do. So everything above this line was a dead end. But 1 multiplied by 4, if they're both negative, will still give you positive 4. And that checks out. What about if I take negative 1 plus negative 4? Negative 1 plus negative 4 gives me negative 5. And that is exactly what I need to get. I need to get negative 5. Which means these are the two numbers, negative 1 and negative 4. And those numbers go here and here. So it's going to be minus 1 and minus 4. When we FOIL this out, we get x squared minus 4x minus 1x plus 4, which is x squared minus 5x plus 4. That makes us happy because that's what we're supposed to get. So this is the answer. All right. All right, so the leading coefficient of the first term is 1, which means this qualifies for our little multiplication and addition trick. What I am looking for are two numbers that add to give positive 6, and the same two numbers have to multiply to give negative 16. So every pair of numbers I write will multiply to give negative 16. I don't need to check them. I'm using these numbers because they multiply to give negative 16. So this works. What about negative 1 plus 16? Well, I don't need to write down what that is. It is not going to give me 6, which is what I want. You don't need to do every one. I think most of you will understand that this is going to be a dead end by just switching the negatives. If I try 1 plus negative 16, that's not going to give me what I want. You can try negative 4 times 4. That gives you negative 16. But unfortunately, negative 4 plus 4 does not give us what we want. You can try negative 8 and 2. That gives you negative 16 when you multiply. What about negative 8 plus 2? That does not give you the negative 6. It does not give you the positive 6. It gives you negative 6, and we want positive 6 for a sum. However, 8 multiplied by negative 2 gives you the negative 16, and 8 plus negative 2 gives you 6, which makes us happy, which means the numbers are 8 and negative 2, so m plus 8 and m minus 2. We don't need to check that. If you want to FOIL it out and confirm that it works, that's fine. A final comment on this question before we go on. All of this stuff over here, with experience, you will not need to write down as much. I knew by just looking at this that it had to be 8 and negative 2. And I hope that of the 9 or 10 students in 10C right now, I hope that at least 2 or 3 of you are starting to pick up on that you can do this kind of thinking in your head instead of writing all this stuff down. All right, let's take a look at D. Well, we can't do D because the coefficient of the first term is not 1. But I notice that there is a greatest common factor of 2 in all 3 of these terms. So I can factor the 2 out and be left with p squared minus p minus 12. And that means, since the coefficient of the first term is 1, I can use this little trick. By the way, the middle coefficient is negative 1. So we are looking here at two numbers that multiply to give negative 12, but they have to add to give negative 1. So you can try the combinations with 6 and 1. If they have to multiply to give negative, it's negative 6 and 1, or it's 6 and negative 1. You'll discover that these two fail the addition test. Neither pairs of these numbers add to give negative 1. So maybe you try 4 and 3. Maybe you try negative 4 times 3 which of course gives you negative 12, and to boot, in the words of my grandpa, negative 4 plus 3 gives you negative 1, which is what we want. We want a negative 1. So that means it's p minus 4 and p plus 3. Another one with a common factor. Take the 5 out. You're left with m squared plus 3m minus 4. So you are after two numbers which multiply to give negative 4. Those same two numbers add to give positive 3. Go ahead and pause the video and find the two numbers. All right. Well, the numbers would have been positive 4 and negative 1. When you multiply 4 by negative 1, you get the negative 4, which is what we want. When you take 4 plus negative 1, you get positive 3, which is what you want, which means we're done. All right, something a little different. I know that this will be confusing, but once you see it in action, it's going to be pretty simple. I want to just clone this and ask you to imagine that this is in fact what the question is. B squared plus 5b plus 6. Okay? And what you would do is factor this in no time flat, because of course you're getting better and better at this. You would say I have a b here and a b here. What two numbers multiply to give 6 and add to give 5? I guess that would be plus 2 and plus 3. But then we come back to reality. And the reality is when we multiply these two things together, we don't want to get 6. I mean, we do over here. 2 times 3 will give us the 6. But the reality is we want to get 6c squared. And that is so easy to fix. All we do is we put a c here and a c here. That's it. If we FOIL this out, b times b is b squared. My outer is 3c times b, which is 3bc. You can see I'm building bc terms now. My inner is 2c times b, which is 2bc. And my last is 6c squared, and it all checks out. G, same kind of thing. X, just throw a y in here and here. And now we're going to find the numbers that multiply to give negative 20, and these same two numbers have to add to give negative 2. So now we start crunching numbers. What are some numbers that multiply to give negative 20? Negative 2 multiplied by 10. 2 multiplied by negative 10. 5 multiplied by negative 4. Negative 5 multiplied by positive 4. We got 5 times 4. We have 2 times 10. I think that's it. None of these pass the sum test. These two numbers, negative 2 plus 10, do not give us negative 2. 2 plus negative 10 does not give us negative 2. 5 plus negative 4 does not give us negative 2. Negative 5 plus 4 does not give us negative 2. So what on earth does that mean? What it means is this is not factorable. And as you progress through the grades, you'll find out that certain things are not always possible, but they still have meaning. This expression still has some value in mathematics, even though you can't factor it into two binomials. We have one more to go. Again, two variables, that's okay. We put an m here and an n here, an m here and an n here. And the two numbers have to multiply to give negative 12. The same two numbers have to add to give negative 1. Again, pause the video on your own and find the numbers and then resume the video. Negative 4 and 3 work. So this factors into m minus 4n and m plus 3n. And that's it. That's the lesson. You have a large number of questions that you can go to for practice here. You want to get fairly proficient at doing these, which means it shouldn't take you more than a minute or so when you're getting better to factor these. Some of you will burn through these and you'll be able to do them in 30 seconds each. The rest of you, or some of you rather, may take 3 or 4 minutes per question initially. But the hope is that after you do more and more, you get better and better. Again, this is not the kind of thing where you spend 5 minutes on math and then do something else. You have to do dedicated practice every day with this stuff. That means at least a half hour working on it. And then come back and do a half hour more later on. Anyway, I hope that made sense. Once again, I always hope it makes sense. And I hope you're doing well. And hopefully I'll see you soon in the classroom. Take care.